Good morning, dear student. In previous lecture, we discussed the introductory part of our chapter magnetic material, that is magnetism, and what is the basic source of magnetic material, or which factors which is responsible for magnetism in magnetic material. In this lecture, we will discuss some important definitions which is very useful in studying the magnetic materials. The first one is the magnetic flux. The first definition, that is magnetic flux. The first definition is magnetic flux. So, what is this magnetic flux? Magnetic flux is a measurement. Is a measurement. Magnetic flux is a measurement of total is a measurement of total magnetic field, total magnetic field which passes which passes which passes through a given area, through a given area through a given area. So what is this magnetic flux? Because magnetic flux is measurement of total magnetic field which passes through a given area. Because we know that magnetic material, if you consider which material is considered as a magnetic material, because we know that the electrons have a random motion. If you consider a normal material without applying any external magnetic field, we know that the electrons having its motion, and which contributes the magnetic moment. But sometime the material can be magnetized by applying the external magnetic field, and the behavior of these electrons in external magnetic field results into the materials, either temporarily magnetic material or permanently magnetic material. So by the application of magnetic field, external magnetic field, we can convert any material into temporary magnetic material or permanently magnetic material. So this magnetic flux, what is this magnetic flux? Magnetic flux is a measurement of total magnetic field which is passes through a given area. So it is an external magnetic field which is applied to the material, which causes magnetism in the magnetic material, which causes the magnetic properties in that material. So what is this magnetic flux? It is a measurement of total magnetic field which passes through a given area, or the another definition is that, or the total number of magnetic lines of force is produced is called magnetic flux. The total number of magnetic lines of force, the total number of magnetic lines of force produce the total number of magnetic lines of force produced is called as magnetic flux, is called as magnetic flux. Because to convert any material into a magnet form, we required external magnetic field, and the behavior of any material in case of magnetic field uh, can be the behavior of any material in magnetic field. Classify the material into different types. So the types of material we will discuss in the next lecture, that is either it is diamagnetic, paramagnetic, ferromagnetic, antiferromagnetic. So the first important definition is that the magnetic flux, so it is a measurement of total magnetic field which is passes through a given area. So from given area, how much magnetic field is passes is called magnetic flux, or in other word, we can say that the total number of magnetic lines of force produced is called magnetic flux. It is denoted by symbol phi. This magnetic flux is denoted by symbol phi, and its unit is Weber. Its unit is Weber, WEBER, and 1 Weber, which is equal to 10 raised to 8 lines of force. 1 Weber, which is equal to 10 raised to 8 lines of force. So this is the first definition. At least you should know the definition, understand what is this magnetic flux density. So at least you should understand only the definition. We are not getting into very much details into this magnetic flux density. It is a measurement of total magnetic field which passes through a given area, or the total number of magnetic lines of force produced is called magnetic flux. Let us discuss the second definition, that is magnetic flux density. The second, that is magnetic flux density. Magnetic flux density. Magnetic flux density. Magnetic flux density. It is denoted by symbol capital B. It is denoted by symbol capital B. Magnetic flux density. The magnetic flux density at a point is a flux per unit area. So it is a flux. It is a flux per unit area. It is a flux per unit area. So B, which is equal to phi upon A. So we know that the unit of phi is Weber and the area, that is meter square, or the unit of this phi is Tesla. So it is the ratio of magnetic flux to that of area. So it is a flux per unit area, magnetic flux density. So you should remember what is this magnetic flux density. Magnetic flux density at a point is a flux per unit area, that is B, which is equal to phi upon A. The next definition, it is the permeability. The next definition is the permeability. Permeability. The next definition is permeability. The ability of material to conduct magnetic lines of force through it is called permeability. The definition is the ability of material to conduct the magnetic lines of force, magnetic lines of force. The ability of material to conduct magnetic lines of force through it is called permeability. So we know that depending or we can say the behavior of the material in case of external magnetic field, that is either the magnetic lines of force are passes through material or not, they are classified into different types, that is diamagnetic material. So we know that from the diamagnetic material the magnetic lines of force cannot be passes, but in case of paramagnetic material there is unpaired electrons, so magnetic lines of force are easily passed from this paramagnetic material. So what is this permeability? The ability of material to conduct magnetic lines of force through it is called permeability. It is denoted by symbol mu, which is equal to mu 0 into mu r. So what is this mu 0? The mu 0, it is the permeability of air or vacuum. permeability of air or vacuum, air or vacuum, and mu r is relative permeability of material, relative permeability of material, relative permeability of material, relative permeability of material. So uh, this is regarding to the permeability. So magnetic flux, then magnetic flux density, the third, that is permeability. Let us discuss the next definition or the relation. Let's discuss it. That is the relation between B and H. A relation between the relation between capital B means magnetic flux density and H, applied field strength, applied magnetic field strength, applied magnetic field strength, that is magnetic flux density, magnetic flux density and applied magnetic field strength, applied magnetic field strength, applied magnetic field strength, that is the relation between magnetic flux density and applied magnetic field strength. So this magnetic field density produced in a material is directly proportional to the applied field strength. So the magnetic field density, that is the flux per unit area which is produced, it is directly proportional to the applied magnetic field strength. So at least you should remember the relationship between B and H. The magnetic, whatever the magnetic flux density is directly proportional to the applied magnetic field strength. The next is the influence of external magnetic field. So what is actually happen, that is we know that the behavior of the material in case of external magnetic field classify the material into different types. So let us discuss the influence. What is actually happen in case of magnetic field? Influence of external magnetic field. Influence of external magnetic field. What is actually happen in case of external magnetic field? We will discuss in with the help of diagram. Let us discuss this diagram. This is a material. The materials having atoms and atoms having the electrons, and the electrons having a random motion. The electrons having the random motion. In case we cannot apply the external magnetic field, that is B is equal to 0, and due to this the magnetization is also 0. The material cannot passes the magnetic lines of force from this through it. Therefore when B is equal to 0, the M is also 0. That is B is what? The external magnetic field, it is not applied to the material, and therefore the magnetization is 0, because the motion, and there is a random motion of electrons into this material, and the material having the volume delta phi, delta phi, magnetic material having volume, that is delta phi. So this is the case, the influence of external magnetic field. When there is no external magnetic field, the net magnetization is 0, and there is a random motion of electron. The random motion, the random motion of electrons, and the magnetization is 0 due to the random motion of electron. The magnetization is 0 due to the random motion of electrons. But what happens when we apply the external magnetic field, that is sorry, when B external is applied, that is, look at that here, we can write here the direction of the external magnetic field. So these are the magnetic lines of force. 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 The direction of magnetic lines of force, and the direction of the electrons, that is the random motion of electron, it get changed. That is, the direction of the electrons and the direction of magnetic field is same, that is alignment. So we can say that more or less align themselves with the applied magnetic field. The electrons, it is also act as a magnet, or we can consider it as a teeny magnet, and there is an alignment with external magnetic field. So whatever the direction of this magnetic field, magnetic lines of force, same is the direction of the electrons, and therefore the material is get magnetized. That is, it can passes magnetic lines of force from through it. It can passes magnetic lines of force through it in case of B external. So in this case, the magnetization, it is not equal to 0, because the material get magnetized, because the direction of the magnetic lines of force and the electrons is same, and therefore it can easily, the magnetic lines of force can easily pass through this material. The material get magnetized, and therefore the net magnetization is not equal to 0. So this is the actual phenomenon, that is the effect of external magnetic field. What actually going on in case by applying the external magnetic field, what is actually happen? So the random motion of electron is convert, uh, or they get aligned with the external magnetic field. So this is all about some important points regarding to the magnetic material. In the next lecture we will discuss what is this magnetization, what is saturation magnetization, and we will solve different numericals on this saturation magnetization. Okay, thank you.